Hey everyone, welcome back to Cam Room 5. So today's video is going to be about the idea of extraction of aluminium using the process of electrolysis. So for the past few videos we have been talking about electrolysis, the conditions required for it, and obviously how various chemical processes are required in electrolysis. When we talk about aluminium, so aluminium is a metal which is higher than carbon in the reactivity series. And if you have watched the videos on metals, you would know that if some metal is higher than carbon, then it's a reactive metal. I was going to write very reactive, but that's not true for aluminium. So it's reactive element. And since it's a reactive element, it cannot be reduced from its ore by the carbon reduction process. So it cannot be reduced from its ore by carbon reduction. You can't heat it with carbon and expect it to be reduced. For example, if you have the ore of aluminium, which is known as bauxite, Al2O3, and if you heat it with carbon, you're not going to see any reaction because carbon is lower in the series. Carbon is not going to replace the aluminium. So you need to go for the process of electrolysis, where you reduce the element by passage of electric current. The electrolysis of the molten ore occurs because if it was aqueous, it would be having hydrogen ions as well. So an aqueous solution, which is not possible for aluminium oxide since it's not soluble, but let's suppose hypothetically if you make an aqueous solution of aluminium's ore, there would be H plus ions, and since the H is lesser in the reactivity series, it's lower, the H will reduce itself, so aluminium won't be reduced even then. Now coming back to the extraction process, you have a steel case, then you have graphite anodes and cathodes. They're connected by a copper wire. And then you have the molten electrolyte. You have a steel case in the surrounding, which is going to obviously tolerate the higher temperatures on the insides. A graphite, which is pure form of carbon. Graphite is used to make the cathode because it's connected from the negative terminal. And you have graphite blocks in the center, which are anode. So graphite cathode is on the lining of the steel, and graphite anodes are hanging in the middle of the molten electrolyte because anodes are connected to the positive terminal. You have almost 6 to 7 volts of voltage being supplied to the anodes and cathode. The electrolyte is molten aluminium oxide. Aluminium oxide is the ore, which is obviously known as the bauxite, as we just talked about. There's another thing that you add over here. Let me write it. Yeah, I don't know why I write often like that. So that's the other substance you have over here is cryolite. Now what is it? It's sodium aluminium fluoride, Na3AlF6. Why do we add it over here? Because it's added to decrease the melting point of the aluminium oxide or the ore. Because otherwise you would need to reach a very higher temperature, and that is going to cost you for the fuels. So you save the fuel cost by reducing the melting point. You have aluminium ions in the molten electrolyte, and you have the oxide ions, as you can see from the chemical formula and from the diagram as well. So over here, Al2O3, I have multiple aluminium ions, multiple oxide ions here as well. Now when we talk about it, you need to know that aluminium ions are the cations, so they're going to go towards the cathode. Oxide ions are the anions, so they're going to go towards the anode. At cathode, reduction happens. So aluminium ions will gain electrons to make aluminium atoms. Now aluminium has a charge of +3, so it's going to gain 3 electrons and become molten aluminium. And the molten aluminium is going to be collected at the surface of the cathode over here. So molten aluminium is continuously collected on the surface lining of the cathode, and it's going to be later tapped out. It's liquid aluminium being collected, just so you know. However, on the anode, what you have over here is oxide ions with a charge of -2 lose their 2 electrons and become oxygen atom. Now oxygen atom isn't stable, right? So you need 2 oxide ions releasing 4 electrons and giving you 1 complete oxygen molecule. Oxygen molecules are produced on the anode, so you can see bubbles of colorless gas on the anode. And this is the oxygen gas being collected. So the observation is bubbles of colorless gas, while aluminium is liquid aluminium on the cathode's lining. Now you need to know that since oxygen is a very reactive gas and the anode is made up of carbon, so oxygen can burn the carbon of the anode to make either carbon monoxide, balancing this equation, or the oxygen can react with the carbon to make carbon dioxide. And that is why the anodes are gradually wear off, they gradually wear off and you want to replace them. So on the anode you can have oxygen, carbon monoxide or carbon dioxide released. Quickly revise it. Aluminium extraction requires aluminium ions and oxide ions from the liquid ore. Cryolite is added to reduce the melting point. Aluminium ions going to the cathode, oxide ions going to the anode. Aluminium ions are reduced on the cathode, oxide ions are oxidized on the anode. Aluminium is collected on the cathode, while oxygen or carbon monoxide and carbon dioxide on the anode. Let's talk about the properties of aluminium. Imagine you have a can of aluminium which has the metallic bonding of aluminium. Now in the surrounding you have air along with moisture, and you can see the aluminium's metallic lattice over here in this bigger magnified diagram. Now oxygen molecules are going to corrode the aluminium. So aluminium will react with oxygen to make aluminium oxide. You want to balance this equation, so at the end you get aluminium oxide after the corrosion of aluminium. And it makes a layer of aluminium oxide on the surface of the aluminium. So you get a layer of aluminium oxide which is an impenetrable layer, unreactive layer, productive layer of aluminium oxide on the surface of the remaining aluminium. This layer is a protective covering on the remaining aluminium. I'm not saying aluminium did not react at all. All I'm saying is aluminium reacted and made a protective layer to protect the remaining aluminium. And that makes the aluminium pretty less reactive. So aluminium is resistant to corrosion because it corrodes initially, it's not a question, but it makes a layer of aluminium oxide which protects it. So it's a use that it can be used to make food cans, because the aluminium is not going to react with the contents on the inside. It's not going to rust itself, it's not going to corrode, I should say. And it's neither going to react with the juices or the contents, whatever is there in the food can or whatever kind of can you're using. Another property of aluminium includes its lesser density, so it's lighter, and that's why it's used to make airplane bodies. It's also a good conductor of electricity, which is why it is used to make wires. So it's lighter and at the same time a good conductor of electricity. Since it's a heat conductor, you can make saucepans from aluminium. So these are the uses and properties of the aluminium. I hope you're clear with us, and we're going to be talking about some new topic in the next video. Stay tuned, guys. Thanks.